Okay, today we're going to talk about the product rule and the quotient rule and how to use them to find derivatives of functions. So let's say we need to find the derivative of this function right here. Okay, so we know that we can multiply these two, and that would give us y is equal to x to the fifth power. And using the power rule, we can find the derivative. Right, y prime is going to equal 5x to the fourth power. Right, so here's one way to find the derivative. Okay, now let's think about something. What if we take the derivative of these separately, okay, using the power rule? Would that give us the same answer? Right, so let's take a look. So if we have y is equal to x squared times x to the third, if we take the derivative of this using the power rule, that would be 2x. If you take the derivative of this using power rule, that would give you 3x squared. Now if you multiply them, right, that would give you 6x to the third. You notice here we don't get the same answer. Okay, so what does that tell you? That tells we know that this is the right answer right here. This is the correct answer for sure. If you take the derivative of these separately and then multiply them, it does not give you the right answer. Okay, so this is the incorrect way to do this. So you cannot take the derivative of functions separately, then multiply them and expect to get the right answer. Okay, now what we do have, all right, in calculus is the product rule. Okay, and let me introduce to you the product rule, which says this. So if you want to find if you need to take the derivative of two functions that are being multiplied, right, this is what this means right here. You take the derivative of the first function, right, f prime, the first function, times the second function, right, plus the first function times the derivative, right, of the second function, in this case g. Okay, so all it is here's our first function, here's our second function. All right, f is the first one, g is the second one. Take the derivative of f, multiply it with g, plus f times the derivative of g. Okay, and these two mean the same thing. Okay, just written in different notation. So instead of f prime here, all right, we're just using the notation, all right, d over dx to represent take the derivative, all right, with respect to x. All right, so over here, take the derivative, all right, with respect to x of the function g. Okay, so these two mean exactly the same thing. I'm just giving you both notations so that you understand, depending on how it's written in a book or something like that. All right, so let's take a look at the product rule at work. Okay, so let's take a look at this example right here. All right, so now I know that we can distribute this. Right, I mean you can distribute this and it'll get you x to the fifth power minus 5x to the third, and then you can use the power rule, okay, to find the derivative of this. Yes, you can do that, and that's probably your best bet. But later on, you won't be able to do this later on, or you don't want to, because imagine if let's say the problem was like this. Let's say there was an exponent here, and it was 8. Are you really going to want to FOIL this 8 times? Probably not, right? So later on, you're going to have to use the product rule in addition to another rule called the chain rule that you'll learn in the future in order to work out problems like this. Okay, so I know right now you can just distribute and use the power rule, but later on you will need the product rule. Okay, it'll be necessary. So let's figure out the answer to this using the product rule, so we get used to utilizing the product rule. So to find the derivative, all right, of y, so y prime is going to equal, so this is our first function, this is our second function. So it says we're going to take the derivative with respect to x, right, of the first function, which is x squared, times our second function, minus 5x, plus, and then we have the first function, x squared, times, and then we're going to take the derivative of the second function. Okay, so this is alright, this is the product rule. Alright, take the derivative of the first function times the second plus the first function times the derivative of the second function. Right, so derivative of the first function is going to be right here. You just use power rule. We're going to end up with 2x times x to the third minus 5x. Then over here, plus, we have x squared. Take the derivative of the second function. Right, so times 3x squared minus 5. Okay? And then what you want to do is you want to make sure you finish simplifying this problem. We're going to multiply 2x times this, so we're distributing. That'll give us 2x to the fourth power minus 10x squared plus, same thing over here, we're going to distribute the x squared to this and this. We get 3x to the fourth minus 5x squared. And then now we need to combine like terms. Alright, combine like terms. So these are like terms right here. That gives us 5x to the fourth. Alright, and then these are like terms right here. That will give us negative 15x squared. So the derivative, y prime, right, is equal to 5x to the fourth minus 15x squared. Okay, and if you want to check just to verify, let's distribute this right now. So then that'll give us x to the fifth power minus 5x to the third. And if you use the power rule for this, right, this is going to be 5x to the fourth minus 15x squared, right? So like I said, if I was to get this problem on a test or quiz right now, I would just distribute this, use power rule, and get the derivative right away. Okay, but like I said, we're gonna need the product rule. Like if you have an exponent here later, you're gonna have to use the product rule. So right now, just to verify that the product rule does work, because you notice we do get the same answer right here. Okay, so let's take a look at another example. Okay, so let's take the derivative of this function here, right? So we have two functions, right? We have two functions here being multiplied. Okay, so we're going to use the product rule. All right, and like I said, yes, I know I can FOIL this and then just use the power rule. But if there's some sort of exponent, let's say this is like to the 10th power, you're not going to want to do that later because you're going to get a huge polynomial. It'll take you forever. Okay, so for now we're just practicing the product rule because we will need it later. So I'm going to find the derivative using the product rule. So we have f prime of x is equal to, and make sure you write the notation and everything. So we're taking the derivative of this first function. So we're taking the derivative with respect to x of the first function, 3x minus 2x squared times 5 plus 4x plus the first function, 3x minus 2x squared times the derivative of the second function, which is 5 plus 4x. Okay, so then we're going to end up with f prime of x is equal to the derivative of this. We're going to get 1 times 3, which is 3, minus 4x times 5 plus 4x plus, over here we have 3x minus 2x squared times the derivative of the second function. In this case, it's going to just give us 4. Okay, and then let's FOIL over here. All right, so we're going to FOIL over here. So 3 times 5, we get 15. 3 times positive 4x, that gives me positive 12x, negative 20x, right? So that'll give me negative 8x. And multiply there, that's going to give me negative 16x squared. Plus, over here, distribute the 4, we end up with 12x minus 8x squared. And then let's combine like terms now. That gives us negative 24x squared plus 4x plus 15. Alright, so f prime of x, our derivative, is equal to negative 24x squared plus 4x plus 15. Alright, and don't get lost in all this work, right? You have to remember what you're finding. When you find this right here, when you find the derivative, this means that you have just found the equation to find the slope, right, of the tangent line, right, at a specific point that you need. Okay, so this is the equation to find the slope of the tangent line to this curve, okay, to this curve, right here. So the derivative is the equation to find the slope when you need it. So don't ever forget that. Okay, so do you think you can take the derivative of the numerator and denominator and then divide them? Well, if we take the derivative of the top, that's 2x. If we take the derivative of the bottom, that's a 0, because the derivative of a constant is 0. Obviously, we can't divide by 0 in math, so this is, this is not possible. This is incorrect. Okay, what's the correct way to do this? Well, you should split this up so that it's x squared over 3 minus 1/3, right? So this is kind of like a 1 right here. So when you take the derivative of this using power rule, that's going to give you just what? 2/3 x, right? 2/3 x, and then this is going to be basically 0, right? So the derivative, the correct answer is this, right? So obviously you cannot, right? You cannot take the derivative of the top and then take the derivative of the bottom, divide it, and expect to get the correct answer. So this is incorrect right here. Okay. Now, what if we had what if the problem was like this? X squared minus 1 over x plus 3. Now, you still cannot take the derivative of the top, take the derivative of the bottom, divide it, and expect to get the right answer. That is completely incorrect. Do not do that. Alright? But this problem, I added this x plus 3, right? Instead of just 3, it's x plus 3 now. So if you were to separate this into x squared over x plus 3, right, and then this will basically be minus 1 over x plus 3. You notice now, you won't be able to use power rule to get the derivative, to get the answer like this. Like this is real nice and easy. We could use the power rule for these individually and get the derivative. But something like this, can't use power rule. Right? Can't use power rule, at least not by itself. So what's going to happen? Right? How do we get the derivative of something like this? That's why we need what we call the quotient rule. Okay, the quotient rule. So let me introduce you the quotient rule now. So this is the quotient rule, right? It seems really complicated, but it's not. Right? As long as you remember this this kind of saying that I'm about to teach you. Okay. So if you need to take the derivative of a function being divided by another function, right? Now let me call this the high function. Let me call this the low function. Okay. So the quotient rule says this. All right. So just memorize this saying right here. It says we're going to take the low function, right? Remember the g of x is the low function. The low function times the high function minus the high function, all right, times the derivative of the low function. All right. So here's the saying. It's called low, all right, d high, because we need to take the derivative of the high function, minus high d low, because we need to take the derivative of the low function. So low function, all right, low d high, right, minus high d low, right, d representing, take the derivative, all over the low function, all right, squared. All right, so the saying is low d high minus high d low, all over low squared. Okay, so just remember the saying, right? The quotient rule is just low d high minus high d low, all over low squared. Okay, and these two mean the same thing. It's just different representation. All right, I'm using f prime here to represent take the derivative of f. Over here I'm using the notation, all right, d over dx. Alright, so these two mean the same thing, just written differently in different notation. Alright, but just remember this saying for the quotient rule: low d high minus high d low all over low squared. Okay, so let's use the quotient rule now and see it in action. Okay, so here's let's say we need to find the derivative of this function right here, right? And I've kind of set everything up already, so we kind of can see everything. So we need to take the derivative of y, right? So the derivative of y with respect to x, right? So dy over dx. Remember, this means the same thing as, you know, y prime. These two are interchangeable. Okay. So we're doing low d high. Here's our high function. Here's our low function. So we've got the low function right here, right? Then we're taking the derivative of the high function. So low d, oops, I don't know what that's about. Low d high, right? Minus, then we've got the high function, d low, all over low squared. Alright, so low d high minus high d low all over low squared. Okay, so the low function, 2x plus 5. Then we're going to take the derivative of the high minus the high function. We're going to take the derivative of the low all over the low function squared. So let's work this out. So we have dy over dx is equal to, so we've got the low function, 2x plus 5. We're going to take the derivative of this, so that's going to give us 3x squared minus 6x minus the high function, which is x to the third minus 3x squared minus 5, and the derivative of the low function, which is just going to be 2. Alright, so let's multiply over here. So this gives us 6x to the third. Multiply over here, that gives us negative 12x squared. Multiply here, that's going to give us a positive 15x squared. Then multiply here, that gives us negative 30x. Now over here, let me just take this 2 and move it to the front here. Okay, so you notice we have this minus sign, so I'm going to take the 2, I'm going to move it over here. Okay. And then I'm going to distribute a negative 2, so I'm taking into consideration the minus sign already. Okay, so I'm distributing a negative 2, so we get negative 2x to the third, right, plus 6x squared, and then plus 10. And then we have 6x to the third minus 2x to the third. Alright, these are like terms right here. That gives us 4x to the third. Then we have negative 12x squared, right? And then 15x squared right here, plus 6x squared. So we've got 21 minus 12, so that gives us 9x squared. Okay, and then we have the minus 30x right here, and then the plus 10, all over the low function. All right, remember this is all over the low function, 2x plus 5 squared. And you do not need to FOIL this right here. You can always just keep it whatever the low function is squared. So don't worry about FOILing this out. Okay. So here's the quotient rule in action. Okay, it's actually very, very simple. Right? Let's take a look at another example. Okay, let's find the equation of the tangent line to the graph of this at x is equal to negative 1. So first of all, let's understand the question. Okay, so basically the question says this: we've got some graph, right? Let's just say there's some graph, right? Let's just pretend this is the graph of this function, right? This is f of x. So at x is equal to negative 1, there's going to be a tangent. Alright, and we don't know what the tangent looks like yet. I'm just kind of drawing something to get you guys to understand the question, right? So at x is equal to negative 1, there's going to be some tangent line to this curve. Okay, I'm not saying this is the correct tangent line for it. I'm just getting you to understand what's happening in this question, what's being asked. So we need to find the equation of this tangent line right, to this curve right here at x is equal to -1. So that's the question that's being proposed, right here. Okay, so let's work it out and see what happens. Now, first of all, you don't want to take this and put it into the quotient rule because the numerator is a fraction in itself, so that's really not nice. So what you want to do is you want to simplify this and make it easier for you. So what we're going to do is we don't want this to be a fraction, so what makes sense to do? Well, if I multiply by x, top and bottom, so when I distribute here, that's going to give me f of x is equal to 3x, right? When I distribute here, look what happens. The x's cancel, that gives me -1. Perfect. It's not a fraction anymore in the numerator. On the bottom, I'm distributing the x, so that gives me x squared plus 5x. Okay, now that this looks a lot nicer, let's throw this into our quotient rule. So f prime of x, right, low d high minus high d low. So if you got low, the low function, alright, derivative of, take the derivative with respect to x of the high function, which is 3x minus 1, minus the high function, 3x minus 1, times the derivative of the low function, x squared minus 5x, sorry, plus 5x. So we've got low, right, the low d high minus high d low all over low squared. So let's work this out now. So we've got x squared plus 5x times the derivative of 3x minus 1, which is just going to be 3, so that's nice. Over here we've got 3x minus 1 times the derivative of x squared plus 5x, so that's going to give us 2x plus 5. Okay, and then let's distribute over here, so we get 3x squared plus 15x over here. Now here's where you have to be careful. I like to work this out first, and whatever I get as an answer, then distribute the negative. Alright, so I'm gonna foil this, so this is going to give me right here 3, I'll work it out up here. This is going to give me 3x times 2x gives me 6x squared. Alright, 6x squared, positive 15x minus 2, so positive 15 minus 2 gives you positive 13x. And then -1 times 5 is -5. And then right here, so I have 6x squared plus 13x minus 5, and then I'm subtracting this quantity, or this value. So what I'm going to do is distribute the negative to everything inside here. So that's going to give me negative 6x squared minus 13x plus 5. So if we combine like terms now, our derivative, right, f of x, or f prime, sorry, not f of x, f prime of x is going to equal, we've got negative 3x squared plus 2x plus 5 all over x squared plus 5x squared. Okay, so now keep in mind, after we've done all this work, what did we just do? Right, what we've done is the derivative, this is the equation to find the slope of the tangent line, right? This is the equation to find the slope of the tangent line, right? So how do we find the slope now of the tangent line, right? This is just the equation, right? Remember, the slope is a number, right? It's a value. So to find the slope now, well, you need to plug in x to find the slope. So this is the equation to find the slope of the tangent line. So to find the slope now, we're going to plug in x. Now, x is equal to -1. That was given to us. So I'm going to plug in -1 into here. So f, -1, right? So -3 times -1 squared plus 2 times -1 plus 5 all over -1 squared plus 5 times -1 squared. So this is going to give us -3 times 1, right, minus 2 plus 5. So -3 times 1, that's -3. So -3 minus 2, that's -5. -5 plus 5, we get 0. So the numerator is 0. Alright, so at the top here, this gives us 0. Divided by, on the bottom here, we just need to make sure this is not going to be 0. So this is going to be 1, right, over here, minus 5. So we get -4 squared is 16. So 0 divided by 16, that tells us that our slope, right, so f prime of -1, remember, this gives us our slope. So our slope is equal to 0, right? So the slope of the tangent line is 0. Okay, let me erase some of this right here. Now recall, if we need to find the equation of the tangent line, right, if we need to find the equation of the tangent line, we need the slope and a point, right? So we know the slope of the tangent line, right? So the slope, all right, of the tangent line right here, all right, of the tangent line is equal to 0. So we need a point. Well, we have x is equal to -1. How do you find y? How do you find the y value of this point right here? Well, to find the y value, you have to remember that you're just going to take x, right, and you plug it back into the original function. So we're going to take x here. To find out y, you plug it into the original problem. Okay, that's how you get your y value. Remember, f of x is the same thing as y. Okay, so remember that. Don't plug it into here, alright, not into the derivative, into the original. So let's plug -1 into here. So we have 3 minus 1 over -1. Alright, so basically that's going to give us 3, right? -1 divided by -1 is +1. So 3 plus 1, so that gives us 4. Alright, over here we have -1 plus 5. That gives us 4, so we end up with 1. Alright, so y is 1. Now that we have a point, we have the slope, we can write our equation of the line. So throw it into point slope, y minus 1 is equal to 0 times x plus 1. And then, well, anything times 0 is 0. So just add the 1 to the other side, so y is equal to 1. Alright, now recall, alright, let me erase this. Now let's think about everything that's going on. So what happens is, so if you have a graph, so let's get a visual of this so we understand what's going on. So the graph is, let's say, something like this. There is a tangent line, alright, I'm trying to draw that a little bit better. A little bit lower. There we go. So at x is equal to -1, right? This line here, right? Now why did I draw it? Alright, this is gonna be, obviously this is +1 right here on the y-axis, right? Because the slope is 0. Our slope is 0, so you need to understand this. If the slope is 0, it's a horizontal line. Okay, it's a horizontal line. That's why our equation is just y is equal to 1. Because anytime you have y equal to something, it's just a horizontal line, right? And horizontal lines, the slope is 0. So this needs to all make sense to you. The slope of the tangent line is 0. Oh, that's why this line is horizontal, right? And then its tangent at what point? Its tangent at what point? At x is equal to -1. Here, x is equal to -1. Right here. Okay. All right. And then the last thing, I just wanted to show this example. We're not going to work out the whole thing. Now, if you were to actually find the derivative of this, the easiest way would be to distribute this, use the power rule up there, distribute this, right? Okay, so the easiest way to work out this problem is to distribute this, right? Get some polynomial and throw it into the quotient rule, right? So basically you're just doing the quotient rule, low d high minus high d low all over low square, right? Now I'm gonna leave it separated like this just so you guys see the product rule and the quotient rule working together. Okay, the product rule and the quotient rule working together. Now here's something you need to understand. Some of you may be confused, like, well, which one did we do first? Did we do the product rule or the quotient rule, right? Well, if you take a look at the problem, what's the main operation that's encompassing the problem, right? It's division, right? We're dividing here. So that means that you do the quotient rule first, right? This is a product rule within a quotient rule. All right, so you have to do the quotient rule first. Okay, so we've got our low function, our high function, and I'm going to keep them separated like this. So we've got low d high, right? Low, take derivative of the high function, minus the high function, right? D, all right, low, right? And we take the derivative of the low function all over the low square, right? So when you finally need to take the derivative of this part right here, okay? So when you need to take the derivative of this top function, you have to notice, right? Because later on you're gonna have to use both the product and the quotient rule and even the chain rule all together for one problem. You have to notice here that, oh, this is a product. I need to use the product, right? The product rule for this right here. Okay, so that's why within here now you're gonna notice inside here now, this is the product rule for these two functions, right? Which is take the derivative, right? Take derivative of the first times the second, plus the first function, right? Times the derivative of the second. All right, so within here, when you take the derivative of this, it becomes a product rule right here. So that's how this is an example of how they work together. And I guarantee you will get problems later where you need to use both in addition to chain rule. Okay, and you'll learn the chain rule in a moment, right?